Hello everyone. Today I'm going to be talking about pure substances and mixtures. So when I'm saying pure substances and mixtures, these are both different forms of matter. Remember, matter we've been talking about over the past couple weeks is something that has weight and it takes up space, right? So now we're going to break down matter into two categories. We have pure substances. It's only made of one kind of thing and it can't be physically separated. That's the two important things to remember about pure substances. It's one kind of thing. Versus mixtures is a blend of substances, so it's multiple types of thing, and they are not chemically combined, so they can be physically separated. Physically as in through evaporation or filtering or things like that. So mixtures are like multiple things put together, and pure substances is like one kind of thing. And then we'll break those down further. So pure substances, one type of pure substance is elements. We've talked about elements last week, right? They're the simplest form of a substance. They're the building blocks of all matter of our universe, right? They are found on the periodic table, and each element has its own kind of atom. So a hydrogen atom looks different from a helium atom, which looks different than a neon atom. They all have their own individual atom. But elements is just one type of pure substance. The other type of pure substance are compounds. So compounds are two or more elements that are chemically combined, meaning there's like a chemical bond that happens between them, like a really strong bond that brings them together. So it's like a chemical thing so that they cannot be physically separated. So no filter or any form of evaporation is going to take those apart. Those compounds are stuck together very, very tightly. So compounds are often written in a chemical formula. So we've heard water being referred to as H2O. That's our chemical formula, right? H being the hydrogen. So we've got two hydrogen, H2, and then we've got one O, oxygen. So our chemical formula tells us which elements are involved in its compound. So hydrogen and oxygen versus we have carbon, hydrogen, oxygen all in one compound. So we can also call compounds, they're a type of molecule. That's another nice word for them. But we use compounds, or we are familiar with a lot of compounds, whether we're aware of it or not. But some very daily life examples are water, like I already talked about, glucose, which is the sugar in our body that helps us have energy, and then table salt, right? I don't know if I mentioned, but sodium chloride, remember in our flame test last week, we burned some sodium chloride, NaCl. Well, that's just another way of saying table salt. So pure substances can be elements and they can be compounds. So let's look at more of a visual of that. So here's our breakdown of pure substances. They can be elements. We have all our little zinc atoms here, and we have all of our little chlorine atoms here. They're all on their own. They're individual atoms of a specific type of element. Versus our compounds over here. We have sugar, CHO. The carbon, the hydrogen, the oxygen are chemically bonded. They're stuck together in that chemical bond, so they're not going to be broken apart by physical ways. Same with our water down here, our H2O. So those are our two types of pure substances, and maybe this will become clearer once we put it in contrast with our mixtures. So mixtures, once again, are when we have two things mixed together. So two or more substances, and now they are physically combined, not chemically. They don't have that strong chemical bond. They're just physically mixed together. So because there's not that chemical bond, each substance retains its own properties. So they are more loose. They're just kind of together. They're not bonded together. So mixtures can be therefore separated physically through filtering, sorting, evaporating, things like that. These kind of physical things that we can do to it will bring the two substances apart. So when we talk about mixtures, we think of homogeneous and heterogeneous mixtures. So first we'll talk about homogeneous mixtures. If you need a trick to remember, homo means the same, our Latin word. Science loves our Latin, right? So homo is a very common prefix for words, and it means the same. So homogeneous mixtures means that the mixture appears uniform or it appears the same throughout. You can't really see the individual components of it. So for example, like our lemonade up here, lemonade has water, lemon juice, sugar. It has all these different substances in it, but throughout the whole liquid, it looks about the same. Same with our sugar water over here. It has sugar and water combined together, but we can't really see, we don't see those individual sugar particles. It looks the same throughout the whole glass, right? So we can call those things solutions. It's a mixture where the solute is equally distributed within the solvent, meaning the solute, which is the solid, which is, for example, our sugar, is equal throughout the solvent or the liquid water. Another way to think of this, so if we're comparing it back to our pure substances, our sugar water here, if we put our sugar water on a burner and we start boiling it, that water is going to start to boil off, leaving behind that sugar. So that is one way we could separate this mixture. So in contrast to homogeneous, so I forgot to say, so salt water, milk, Kool-Aid, those are all homogeneous mixtures, because we have our glass of chocolate milk here. Chocolate milk has chocolate, it has calcium, it has lactose. Milk has a lot of things in it, but it all looks the same, right? So it's homo, meaning the same. Versus our heterogeneous mixture. Hetero actually means different. It's the Latin prefix meaning different. So heterogeneous mixture is a mixture that you can see this different parts. Like with your eyes, you can see the different parts. Like we have our trail mix here. Trail mix has peanuts and M&Ms and raisins and almonds, and we can see with our eyes all those little different parts. Same with our sand. We have our little clear sand, we have our little brown pieces of sand, we have really dark black pieces of sand. We can see all the individual different types of sand. And when we can see with our eyes all those different parts, it means that it's a heterogeneous mixture. Hetero meaning different parts, different pieces. Same with our oil and water mixture. We can see the different parts. So this is just a look at the kind of molecular level of some of these things. If we start at the top, we have our elements. Remember, they have their own specific atom. In this box, we have the same atom throughout. In this box, it's the same molecule throughout. Versus our mixtures, we have two different types of things, right? We have two separate things in each one of these. Versus our compounds are our little elements are bonded together. They're stuck together. There's nothing going to separate them apart. So a really easy way to look at all of this, kind of at a farther back angle, we have our matter flow chart. So we start with our matter and we ask ourselves, can the matter be physically separated? So remember, it's that physical thing, right? It's not chemical. So if they're chemically together, they're bonded together, and we ask ourselves, can the matter be physically separated? We'd say no, because there's that chemical bond, that strong bond. So we would know it's a pure substance. From there, we can say, is it made of just one kind of atom? If that's a yes, it's an element. If it's a multiple element compound, remember with our formula, it's a compound. If we start back up at the top and we ask ourselves, can the matter be physically separated? Meaning through evaporation or filtration or something like that. And if the answer is yes, we know we have a mixture. We have two different types of things, types of substances in one place. From there, you ask, can you see the different parts? Yes, heterogeneous, or no, homogeneous. So that's the basics of pure substances versus mixtures. There are some review questions on the next couple slides if you want to take some time, if you feel like you need a little bit more clarification or more practice with this, go through some of those. If you are ready to move on, that's totally fine. Move on to the next thing on the agenda.